Okay, so looking at kinetic friction, we needed to see, and I need you to see that kinetic friction is attached to the normal force. Okay, so it's proportional. So it has, its value is connected to the value of the normal force. And there's a way that I want you to see this. So if you rest your hand on the table very lightly, whenever you get done writing this, rest your hand on the table lightly and try and slide your hand and see how much force it takes. Okay, if your hand is resting lightly on the table, I want you to see how much force it kind of takes there. Okay, so as you push down on the table, the normal force will increase, which will increase then kinetic friction. So this is the equation that we use to solve for friction, and I'll write it a little bit bigger here. But what it says, force of friction, F sub F, is equal to the coefficient of kinetic friction. That's what this little symbol means, coefficient of kinetic friction. Equals that times the normal force. Okay, we said that the normal force is proportional to the frictional force value. So we have to put it in the equation. This is our only equation that we use that mixes horizontal and vertical, right? Normal force is a vertical force. Friction is a horizontal. This is the only one that does that. So you need to be able to calculate both of those things. Coefficients are given to you, okay? They're not something that you'll have to memorize, but each surface or pair of surfaces has a specific coefficient of kinetic friction that you'll plug in. Typically, they're decimal numbers. They're typically 1 or below. Sometimes you'll see them a little bit bigger than that, but very rarely they're usually 1 and below. So you'll have coefficients of kinetic friction that are given to you, or possibly that you'll have to solve for. Okay? So everyone have that equation down? Yeah, this is a Greek symbol. Do you know what this Greek symbol is called? Mu. It's called mu because it looks like kind of an M and kind of a U. I'm sure that's not why it's called that, but it is. Okay. So the second part of friction that we're going to talk about is called static friction. What do you think the word static means in this situation? Constant. Yeah, constant or sitting still. Kind of, we think of stagnant or static. Okay, so static friction is the frictional force that's exerted on an object when it's at rest. Okay, so if something's sitting there, it's got a certain amount of friction that it has to overcome then to begin its motion. So when an object is at rest, it's got a certain amount of friction that it has to overcome. And that's what I just said. Okay. So our equation here is essentially the same. They label it just a tiny bit differently. They say F max equals mu s times the normal force. And F max is still our frictional force. Okay, the only reason that it's labeled F max is because it's the maximum amount of friction that an object can have that's keeping it still. Okay, so that's the maximum amount of friction that that object has to overcome in order to begin its motion. So you can still think of it as a frictional force. I'm okay if you still label it F sub friction. That's fine with me. Okay, this is just how it is given. So we have mu, and then what does the S stand for? Static. Good. The other one is UK or mu K. We're going to work with kinetic friction a lot more than we work with static friction. So you'll use the other equation more than you use this one anyway. All right. We don't care about this part. Okay. All right. Let's just jump in and do some practice problems. So what's going to happen is when we're looking at these problems, you're going to use the same kind of process for nearly all of them. So I'm going to walk you through step by step, so hopefully that you get the process down and the steps down. Okay? So this says a sled with a mass of 50 kilograms is pulled horizontally along a flat, snow-covered surface with a force of 75 newtons. The coefficient of friction is 0.010. So before we can do anything, we want to draw our free body diagram. How many forces will this object have on it? Okay, you say 3. What are they?
Like gravity,
Okay, the normal. That's called the normal. Anyone else? Yeah, Margaret, what do you think?
The friction and the force pulling it.
Yeah, we're going to have 4 forces in our diagram here. And we're going to have some sort of applied force that's pulling it. Or we could call this F sub P for pull, or however you'd like to name it is fine. All right, so we have our frictional force here. How do we know there's a frictional force? Yeah, it gives us a coefficient of kinetic friction. Okay, it gives us that. So that means we know we're going to have friction. Okay, we're going to have to deal with that. So before we can do anything, our first step is to define the force of gravity. So how do we go about solving for F sub G? Mass times gravity, good. So 50 times 9.8. And we get, you need to have your calculators out. So you can be walking along with us here. 490 newtons. Okay, since it's a force due to gravity here, we're in newtons. So that's our first step, is to find force due to gravity. That's going to be our first step for these problems. Find F sub G. All right, so as I click through these steps, my work's going to go away. So do you guys have everything you need to of my work?
Yep.
Not quite. Okay, just one second. What do we know about finding the normal force here? Yeah, it's the same as the force due to gravity. Okay, if we draw our free body diagram again, which you guys have it in your notes, right? I don't need to draw it again. Is this object moving vertically at all? No. So we know that force due to gravity is equal to the normal force. So we know our normal force is then equal to 490 newtons. Okay, and the reason we know that is because we're looking at a vertical force here. We see it's not moving vertically at all. It's only moving horizontally. So those two forces have to cancel out, which means they have to be equal to each other. Does that conceptually make sense? I need like a firm yes or a firm no.
Yes.
Okay. Okay. Good. So we have our gravitational force. We have our normal force. Now we want to calculate the force of friction. So we need to use the equation here that we just learned. So it's force of friction equals coefficient of kinetic friction times the normal force. Okay, so force of friction equals coefficient times the normal. So we want to calculate F of friction. Do we have the coefficient? Yeah, it's 0.010. And do we have the normal force? Yeah, it's 490 newtons. Okay, the coefficients don't have units. So you don't have to worry about that if you're solving for them or if you're putting them in your equation. They don't have units. So what do we get for our frictional force? 4.9. Okay, good. 4.9 newtons. All right, and that would be going in the left direction. We're not super concerned with that at this point, but just for heads up, that would be going in the left, okay, because our applied force is pulling us to the right. So we've got our gravitational force, we've got our normal force, now we've got our frictional force. Let's find horizontal acceleration now. So in order to find horizontal acceleration, that's got to come from our net force equation. So we're going to do F net equals right minus left, correct? Do you remember what our right force was? F applied. And our left force was force of friction. Okay, we have numbers for both of these. Okay, we solved for the frictional force, and our applied force is given to us right here in our problem. So we're going to take 75 minus 4.9. We get 70.1, correct? Okay, so 70.1 equals our net force here. So how do we go from there to finding our acceleration?
Mass times acceleration.
Exactly, we take mass times acceleration. So 70.1 equals mass, which is 50, times acceleration. So we divide by 50, and we get our acceleration to equal 1.4. And units for acceleration are what? Meters per second squared. Excellent. Okay, so our next one says a 225 kilogram crate is pulled horizontally with a force of 710 newtons. If the coefficient of kinetic friction is 0.20, calculate the acceleration of the crate. Okay, so this problem is not walking us through step by step like the last one was. That's why we need to know the steps that go into that, okay, or know our overall goal here. So the acceleration that it's asking us to calculate, do you think we're looking for horizontal acceleration or vertical acceleration? Yeah, horizontal. We're not lifting the box up, we're pulling it to the side. So we're looking at horizontal acceleration here. So if we draw our free body diagram, we're going to have F sub G, F sub N, some F applied or F pull or whatever you want to call it, and we're also going to have friction. All right. So what's our first step then for these problems? We want to find force of gravity because we know force of gravity equals the normal force. Okay? So force of gravity equals mass times gravity, which then equals 225 times 9.8. $2,205. Okay, so that equals F sub G. Now our next step would be to calculate normal force, which is the same thing, exactly. Okay, so we know that that also equals the normal force because it's not accelerating in the up or down or vertical direction. Okay, so it's on the ground, it's sitting on the ground still. So this is our normal force. Now, what can we do next? What can we solve for next? Force of friction, exactly. And do we have our coefficient here?
Yes.
Okay, good. Our coefficient is 0.20. Our normal force is 2205 newtons. What'd you get, Zach?
441.
Perfect. 441 newtons. Okay, that's our frictional force. So now we have numbers for our applied force, which was given to us at 710, and we have numbers for our frictional force, which we calculated to be 441. Those are our left and our right forces. So now we have our frictional force, we have our applied force, and we want to solve for acceleration. So what do? Bless. Good. F net equals F applied minus force of friction. So we're taking right minus left, which means we're taking 710 minus 441. Oh, I'm sorry, I labeled it wrong. Force of friction, not force of gravity. Okay. So 710 minus 441, 269, okay, newtons. Are we done? No. Okay, 269 newtons equals our F net. So we can do a substitution there to make it mass times acceleration. And we know that our mass equals, 225. Acceleration equals 1.2. And what's our units?
Meters per second squared.
Good. Since we're solving for acceleration, it's meters per second squared. Excellent. It'll pretty much always be in those steps. Yeah, I'm going to show you one more that we're going to have to use some components with. Okay, but yeah, for the most part, you're going to have to find the normal force. You're going to have to find frictional force. Or sometimes it will give you a frictional force or a way for you to calculate frictional force, then it'll ask you to solve for the coefficient of friction. So then you have to solve for, you just do it a little, just a little twist. Okay? 1.2. Okay. So this one says a 30-kilogram box is sitting on a wooden floor. A girl pulls upward on the box with a force of 100 newtons at 40 degrees. The box begins to slide. Okay? So this is going to walk us through step by step. Would you guys like to walk through step by step, or can we do it ourselves?
Do it.
Let's just do it. Okay. So let's draw our free body diagram here. This is similar to the ones you guys had a question about on the quiz, okay? So we have force of gravity. We have our normal force. We have some applied force that's at an angle this time. And we have friction. Okay, so she's pulling upward on the box with a force of 100 newtons at an angle of 40 degrees. So 100 newtons is telling us that this force right here is 100 newtons, but it's coming at an angle of 40 degrees. So we can't work with this angle, right? We have to work with force applied Y and force applied X. So our overall goal here is to find our horizontal acceleration, okay? And as we click through it, it will tell you that the coefficient of kinetic friction equals 0.30, okay? So I built it originally that as we click through it, will tell you the coefficient. Since we're not going to click through the steps, I'm just going to tell you up front that the coefficient of kinetic friction is 0.3. Okay, so our overall goal here is to find what is the acceleration of the box. Okay, that's our goal. So if we look at our free body diagram, what forces are we really going to be using?
I don't know.
Yeah, we'll use the normal to calculate frictional. That's fine. We're going to use F of friction, and we're going to use F applied X. Okay? So once we solve for the components of that 100 Newton force that's at an angle, then we're done with the 100. Okay? We have to break that down. So we'll just go ahead and follow our normal steps here. Okay? We're still going to have to find force due to gravity. So let's find that. Okay, so 30 times 9.8. What'd you say, Sam?
294.
294 newtons. Okay. So now we need to solve for the normal force. Is our normal force going to be equal to gravitational this time? No. We got to take into account that applied Y. So force applied Y. All right, so we take this time F sub G is going to equal the normal force plus force applied Y. Okay, does that make sense to everybody? The reason that we can do this is because we know it's not accelerating vertically at all, which means we need to know that the up forces equal the down forces. So these are the up, and this is the down. Okay? So we can plug these in here. Have we calculated F applied Y yet? No? How do we do that? Good. F applied Y equals 100 times sine of 40. Very good. You got 64 point what? 64.3. We're solving for the normal force, and we know our gravitational force is 294. Okay, so move that over and tell me what the normal force equals. 229.7 newtons. Good, 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 good. Believe it or not, we're almost there. Okay, so now if we want to find frictional force, can we do that? Yeah, because we have the normal force and we have the coefficient. So let's find force of friction here. 0.3 for our coefficient. That's given to us over here. And 229.7. Thank you. That's our frictional force then. Okay. Can I get rid of this over to the left side? Okay. So we have our frictional force. We want to find our horizontal net force. So what else do we need to solve for here? F applied x. Okay, how do you do it? Good, 100 cosine 40.
What are we solving for?
We're solving for F applied x because now we're looking at our total horizontal here. Okay, and what'd you get?
76.6.
Okay, so now we can move on to our F net equals our right forces, which is our applied x, and we solve that to be 76.6, minus our left forces, which is friction, and we solve that to be 68.91. 7.69. We can then substitute our mass times our acceleration into this equation, and we can find acceleration. So tell me what you got. 0.26. What's our units? Okay, you did it.